Hello, welcome to this clip going through question 11 from the end of Module 2 practice questions in the textbook, page 88 to 89. So looking at the whole question, it's pretty much about a titration. So it's highly likely we're going to have to do some mole calculations. So wherever necessary, I'll use the DMEMA, data, moles, equation, moles, answer technique, to streamline the mole calculation process and allow you to deal with all the different pieces of data that you're being given. So it says the aqueous sodium hydroxide was to be added to a conical flask for the titration. So what they're asking you to think about is how can we make sure that the only thing coating the inside of the pipette is your sodium hydroxide, because it said it was left unclean, or may have been left unclean from a previous experiment. So what you need to do is rinse the pipette with the same concentration of sodium hydroxide solution that you're going to use it to transfer. So then there'll be no contamination and there'll be no dilution of your sodium hydroxide as you transfer it. So in the next part of the question, it gives you quite a detailed description about what a student did. So you need to think about what the question is describing. So the first part is she filled the burette with sulfuric acid and the burette reading was 0.00. So what that means is she saw that the bottom of the burette was next to the 0 centimetre cubed mark, but she wrote it in her titration table as 0.00 centimetres cubed. So it says she carried out her first titration until the burette reading was 21.55. So you'll notice that I've drawn the burette readings as she would have seen them. So she had to make a judgment call on 21.5 or 21.6, so she went for 21.55. She also had to do the same judgment between 42.2 and 42.3 to make it 42.25. Now at this point, at the end of her second titration, she knows that she's about to run out of sulfuric acid, so she tops the burette, so the burette read 10.0 centimetres cubed, or 10.00. So she's now done her rough titer, her first titer, and her second titer. Now she stops at this point, and we usually say to do 3 full titers after a rough titer, so she must have reached concordancy. So let's work out the titer that she would have ended up with in each case, and then we can make that decision. So you can see from the titers 1 and 2 that they're within 0.1 centimetres cubed of each other. So these are what we'd call concordant. So they agree to within that tolerance, 0.10 centimetres cubed. So now we have to calculate the mean titer. So that gives us 20.70 to plus or minus 0.05. Now what you've got to do is use this calculation, or use this value, to calculate the concentration of the sulfuric acid. So this is where I'm going to use data, moles, equation, moles, answer. So you start with the thing that you have the most information for. So I've collected the information from around the question. I've put in 20.70 that I've just worked out. I've put in 0.106 moles per decimetre to the minus 3 that the question told me. And it's talking about a 25 centimetre cube pipette. So therefore that must be the amount of sodium hydroxide in terms of volume that's added to the conical flask. They just haven't said 25 centimetres cubed of sodium hydroxide is added to a conical flask in so many words. But they've implied it up at the beginning of part A. So if I just draw your attention to that for a second, you can see what it says. The aqueous sodium hydroxide was added to a conical flask for the titration. The student was supplied with a 25 centimetre cube pipette. So that must be the amount that was being added. So the first part of your answer is to calculate the moles of sodium hydroxide. So dividing the volume by 1000 to convert it to a decimetre cubed unit, and then multiplying that by the concentration in moles per decimetre cubed that we were given, that gives us 2.65 times 10 to the minus 3. And we can put that into our data, moles, equation, moles, answer table. So now we can use the equation, and it tells us there's a 2-to-1 mole ratio of sodium hydroxide to sulfuric acid. So I'm just highlighting that up at the top for you so you can see what I mean. So obviously now what we can do is work out the moles of sulfuric acid. So that gives us 1.325 times 10 to the minus 3 moles. So we do this by dividing the moles of sulfuric acid by its volume, which we worked out earlier as 20.70 centimetres cubed. So that now gives us 0.0640 moles per decimetre to the minus 3. I'm sticking it there because it's getting a bit busy and crowded at the bottom of the screen. Clearly on your paper you'd put it below, so it's well out of the way and it's clear that that's your answer. So let's now move down to the final bit. So in this section what they want you to do is calculate the percentage of error in two different transfers of liquid. One transfer of liquid is your transferring of 25 centimetres cubed of sodium hydroxide using the pipette. The other transfer is the measurement you took from two separate readings of your burette. So this brings up what percentage uncertainty actually is. So percentage uncertainty is the absolute uncertainty of your piece of equipment divided by the measurement you've made times 100. But your pipette only requires one reading, you read it off once. In your burette you do two readings, the start volume and the final volume. So therefore the error in the burette happens twice. So with the pipette it's quite straightforward. You take the 0.06, you divide that by 25, which is your measurement, and multiply that by 100, that gives you 0.24%. So for the burette, you take the absolute uncertainty and you multiply it by 2, because you've done two measurements to get one reading. Sorry, I should say two readings to get one measurement. Let me get it the right way around. So 2 times 0.05 divided by your average titer times it by 100, that gives you 0.48%. Okay, so hopefully this has been a useful run through of how to do this type of question. It's more about the techniques and the calculation this time. So as always, thanks for listening and see you soon.